Hi students, Miss Slyman here, and today I'm going to talk to you about hyperbola. So we've seen conic definitions and locus of point definitions of our first three conics, the circle, the ellipse, and the parabola, and today we're going to talk about the hyperbola. So there's a few differences between a hyperbola and a parabola. If this is my plane cutting through my cone, if I continue up this way with the plane that the parabola is in, I'm not going to hit the second cone. The hyperbola would, though, because it's a little bit more vertical. Also, if I think about my definition of locus of points definition of a parabola, I know that what's happening there is that I've got a directrix, which is a line that runs perpendicular to the axis of symmetry, and I've got a point called the focus. And now if I find all the points that are equidistant between going perpendicular from my directrix, so I would go this way, and then find something that's the same length out from the focus. So if I have the same length, maybe it's going to be up here. And so that would be one of my points, and I can continue doing that, and I can continue going along my directrix. And so we know that parabolas continue to infinity. So this is going to go up, and it'll keep going up, and I know that my domain is going to be all reals. So it's going to just keep getting wider and wider as I go further and further up. Well, that's not true with hyperbola. So the definition of hyperbola, similar to the ellipse, so the ellipse I had 2 points, and if I find a common sum as the distance between those 2 points, so whatever that distance is, when I add up those two distances, it's going to be the same for every single point. So adding these two distances is the same as adding these two distances. With a hyperbola, I'm going to do the same thing, except instead of adding the distances, I'm going to subtract them. I get a fixed number, and all of the points that have the difference between the two distances, that same value, are going to make up the points of my hyperbola. And so I have it on both sides. So coming down, points down here, I would go to here and to here. Or if I wanted to find one that was similar to there, it's like here. So now, because I'm subtracting, this is why I'm getting my two distinct values. Sorry, this second one should have come over here. So now I'm here. Come on, make my straight line. Let's try that again. Okay, so in this case, this length would be the D2, and now this length here would be my D1. But again, that difference is going to be the same because I'm thinking of my absolute difference between the two. So I've got hyperbolas making two different branches, but also with those two different branches, because I'm looking at a common difference between the two, I'm not going to keep going out to infinity like the parabola does. Instead, my hyperbola is going to be bound by asymptotes. So I'm going to have asymptotes binding this. Those asymptotes are going to cross at the center, and directly above my asymptote, directly above the center, I'm going to have my vertices. Okay, so that's my introduction to what a hyperbola is. Now let's look at the equation. So the equation of a hyperbola, similar to the equation of an ellipse, involves combining my values and looking at ratios, setting them equal to 1. With an ellipse, I add these things, but the hyperbola, I'm finding the difference. So a hyperbola that opens horizontally, so that's going to be one that looks something like this, has an equation that looks like this. So it's going to start with x squared. This time, a doesn't have to be bigger than b like we have with ellipses. What happens here is that whichever one is first dictates which way the hyperbola opens. So a vertically opening hyperbola is going to start with my y value, so that's going to look like the one that's above, something like this. The vertices, those are going to be the turning points of your hyperbola. So if your center is this point HK, I'm going to add and subtract horizontally to get to the vertices. If this is your point HK, I'm going to add and subtract vertically to get to the vertices. Now the co-vertices, well, remember I told you that there were asymptotes? So I've got my asymptote coming in this way, my asymptote coming in this way. The asymptotes cross at the center. If I go through my vertex up until I hit the asymptote, both ways, and then come across, do the same thing to make a rectangle. Well, now these points directly above the center, those are my co-vertices. So let's look at some of these equations. So again, my foci are c units from the center. Just like an ellipse, c squared is a squared plus b squared. A is my distance from the center to the vertex. So here is my distance A. Here's my distance A, whether it's horizontal or vertical. My transverse axis is the axis that goes between my two vertices and the center. And then the conjugate axis is the one that's perpendicular to those and goes through the co-vertices. My asymptotes cross through the center in the shape of an X. And the equation of my asymptotes, well, let's come down here. So here's a hyperbola. Let's think about what we're seeing here. We've got a center at -2, 3. We have an A value of 4, a B value of 5, because remember this is 4 squared, 5 squared. So I can see from my vertex, which is at the point -2, 3, I'm going to go over 1, 2, 3, 4, 1, 2, 3, 4. I'm going to go up 5, down 5 to get to my co-vertices. Let's think about the equation of this asymptote. Notice that I am going up 5 over 4. That is my B over A value. So this asymptote here, I go through the center. So I'm going to have y minus 3 equals B over A times x minus -2, so plus 2. So I have the equation of my center, and I have my ratio of B over A to find my slope. This is for a horizontally opening hyperbola. What do you think it is for a vertically opening hyperbola? So I'm going to let you explore that. Come up with an equation, put it into Desmos, see what you can. Let's come back up here though, and let's think about our asymptote. So for a horizontally opening one, our asymptote was y minus k equals, so the first asymptote, of course, has a positive slope. The other asymptote has a negative slope. So I've got two asymptotes, so plus minus b over a x minus h. So I would like you to figure out what your asymptote is for the vertically opening one, and then we're going to come back and look at some more examples.